probability distribution is a table or an equation in which each shows the probability for all values of x, which is previously defined. The function of the tables are to demonstrate the outcome of a statistical experiment with its probability of occurrence. Now, I'm going to explain you some really important concepts for you to understand future problems. First, a variable. A variable is a symbol or a letter that represents any specified set of values. When the value of the variable is the outcome of a statistical experiment, the variable is now a random variable. Random variables can be discrete or continuous. They are discrete when you can only take a certain value. For example, when flipping a coin twice, you take the values 0, 1, and 2. And they are continuous when you can take any value within a range. For example, a person's height. In statistics, a capital letter is used to represent a random variable, and a lowercase letter is used to represent one of its values.
To tell you the different cases you might find in this type of problems. The first one is when the problem already gives you a table full with information, like all the x values and all the probabilities of each value. So you just need to find the probability that it's being asked in the problem. The second type is when there's a missing value in the probability column. In most of the cases it's a k, and you have to find the value of k. You find the value of k by adding all the different probability values and make it equal to 1, and then you do mathematical procedures to find the value of k, and then you replace, and that's how you complete the table and then proceed with the exercise. And another case you may find is when they give you a written problem and you have to build the table from scratch.
So we're going to continue with the example. The problem tells us that the formula we need to use is this one. So we replace x in this column, which is 1, in the formula, and it's going to be 1 multiplied by 2 plus 1, and we're going to get 3k. We do the same with the next axis. Then, after getting the k's, the result is going to be this one. So now we replace this k in here, and it's going to give us this result. This one says that x is less than 2, so we don't count the 2, we just count this one. But in this example it says that k is less than or equal to 3, so we do count the 3 and we sum them all, sum these ones, and it's going to give us this result. And it's just the same in letter D and letter E. In letter F it says that x is more than 1, so we don't count the 1. It says that x is less than or equal to 4, so we do count these ones. We sum these ones, and it's going to give us 21 over 35.
We will be solving the probability distribution tables. It's really important to know that sometimes they will give you the table stated before. It's important to keep in mind that the sum of all these numbers will always be equal to 1. They will sometimes give you a missing number. This missing number, to get it, and we need to add all this, which will give you 0.80. From this 0.80 and this 1, we need to get the difference, is 0.20. So this 0.20 is the missing number. And this way we can test it and see if we're correct by adding all this number again, and if it's equal to 1, then it's correct. Sometimes they will give you this kind of table to get k. Know that the sum of all these numbers, it's equal to 1. So we add them all up, it's equal to 1. We take number, or the common factor in this case, which is k. We need k alone, so we divide 10. We need to add another row to the table to substitute this 1/10 in every k that we see. And here will be 4/10. If we add all these numbers up, give you 1. So this is the way to solve the distribution tables.
Probability distribution tables can be used in real life, for example, with policemen. Whenever they want to know the probability of only single riders driving in each car that passes by. Another example can be if you're in a bet, the probability of getting heads on a toss that goes from 1 to 100.